Hi again, welcome back to this segment of our lesson. We are still looking at angles of elevation and depression, but we are going to now use these angles to find the height of a building. So we're looking at another example where we find the height of a building. Now before we do that, let's have a look at what angles of elevation and depression are again. Remembering that when you look up, your line of sight together with the horizontal forms an angle of elevation. And when you're looking down at an object, your line of sight forms an angle of depression with the horizontal, okay? Now, whenever you are looking up at something or down at something, ground level becomes your horizontal, okay? Now, if I were to say an angle of elevation of 60 degrees, okay, now how would that look like? You would imagine your horizontal, okay, and your angle of elevation of 60 degrees, okay? So here's your horizontal, your line of sight forming angle of 60 degrees, okay? If I said angle of depression of 60 degrees, then it would look this way with your horizontal here and angle of depression of 60 degrees here, okay? So horizontal up here, okay? Now, in the next example, we're going to look at another word problem, okay? Now let's say, for instance, Mary has gone down to town. She's taking a walk down in town and she notices a tall building, okay? And she's wondering how tall the building is, right? So let's see. This is example number 2, okay? So let's say Mary. Again, let's draw Mary. All right. Mary. All right. And Mary notices a building that is quite tall and wonders how tall the building is. Okay, now that's ground level. That becomes our horizontal. Okay, so this building is 15 meters away from where she is standing. Okay, let's draw our building. Here we go. All right, that's our horizontal. Okay, so when she looks up at the top of the building, her line of sight forms an angle of elevation, which is 60 degrees. Now, we would have to draw in this to represent her line of sight. Okay. All right, she's looking at the top of the building, and her line of sight forms an angle of 60 degrees with the horizontal. Now, we would need to move a horizontal up here so that it forms a right angle triangle that can be used to help us find the height of the building. Okay, so make sure this line is parallel to ground level. Okay, so here's our right angle. The angle of elevation that her line of sight forms with that horizontal is 60 degrees. Okay, now Mary is about 1.5 meters tall. Now this is important because we are also going to use this to help us. Okay, 1.5 meters tall. Now, Mary is 1.5 meters tall. She's standing 15 meters away from this building, and her angle of elevation as she's looking at the building is 60 degrees. Okay, now how are we going to use this to find the height of the building? We already know that she's 1.5 meters tall, which is part of the height of the building. Okay, yeah. So we are going to use this triangle to find the distance from here to this point. Okay, so let's say this is your unknown, x. Okay, now the distance from here to here is unknown, so we are using the tangent ratio to find x. Okay, let's see. 60 degrees is equal to, opposite is x, and your hypotenuse is not given, so you're not using that. You are using your adjacent, which is 15 meters. Okay, right. Bring 15 across. 15, 10, 60 is equal to x. Okay, 15 multiplied by, right? Check the tangent column and see the tangent value of 60 degrees. Okay, according to our tables, that value is 1.7321. Okay, now tangent value of 60 degrees is 1.7321. Okay, we are multiplying here, so be careful. Let's do this here. 1.7321 times 15. Okay, right. 5 times 1 will give us 5. 5 times 2 is 10, carry 1. 5 times 3 is 15, plus 1 is 16. Okay, carry 1. 5 times 7 is 35, plus 1 is 36. Write 6 and carry 3. 5 times 1 is 5 plus 3 will give us 8. Okay, we're not done. Put a 0 here and multiply by the second number. 1 times 1 is 1. 1 times 2 is 2. 1 times 3 is 3. 1 times 7, 7. And 1 times 1 is 1. Okay, now we are adding. 5 plus 0, 5. 0 plus 1, 1. 6 and 2, 8. 6 and 3, 9. 8 and 7, 15. Put 5, carry 1. And 1 is 2. Okay, so we're moving the decimal point 4 times. So from this point, 4 times toward the right. Okay, so we have 1.7321 times 15 gives us a value of 25.9815. So that's the answer down here. X is equal to 25.9815 meters. Okay, so that's the value of X from the top of the building to this point here. Now that does not give us the total height of the building. So what are we going to do? We now need to remember that Mary is 1.5 meters tall. So we are going to add the distance from the top to this point together with Mary's height, which will give us the total height of the building. Okay, so 25.9815 9815 plus 1.5. Okay. 5, 1, 8. 9 plus 5 is 14. Carry 1. 5 plus 1 is 6, plus another 1 is 7. Okay, and we have 2. Right. Again, 4 decimal places, we're simply moving it down into the answer here. Okay, so the total height of the building is 27.4815 meters. So height of the building is equal to 27.4815 meters tall. Okay, if you are asked to round this off to the nearest whole number, then the building is 27 meters tall. Okay, now angles of elevation and depression are very important when we are doing practical applications as the one shown in this example. Okay, what you must remember, okay, is angles of elevations are formed when you are looking upward. Angles of depression are formed when you're looking at in a downward direction. Okay. Another thing you must remember is when you are given a word problem where a practical application is needed, always draw the diagram, clearly put all information that is necessary into the diagram before you can identify the correct ratio to use. Okay, now a clinometer, which I did not mention before, is an instrument used to measure angles of elevation and depression. Okay, surveyors use this, and that is how we know how to find those angles when we use it in a practical application. All right, in our next lesson, all right, we are going to learn about bearings, another practical application of trigonometry that is used in navigation. I hope you enjoyed this part of our lesson. I'll see you next time. Thank you.